Here we are going to be looking at the basic ideas behind the solution of second order differential equations. So let's start by writing a second order differential equation. So this is an example of a second order differential equation. The highest derivative that you see here is d2y dx squared. So therefore this is an example of a second order differential equation. A, B and C are constants. Okay, so I've got A d2y dx squared plus B dy dx plus cy equals to 0. So let y equals to u and y equals to v be solutions of this differential equation. Why do we say this? It will become apparent in a few minutes. So if y equals to u and y equals to v are solutions of this differential equation, we can write this original differential equation as, first let's use y equals to u, so we can write a d2u dx squared plus b du dx plus cu equals to 0. Let's call this equation 1. Then we will use the same for y equals to v. Remember, y equals to v is also a solution of this differential equation, so we can write a d2v dx squared plus b dv dx plus cv equals to 0. So we have two equations. Now what are we going to do next? We are going to take equation 1 and add it to equation 2. So when that happens, you will get this line: a d2u dx squared plus d2v dx squared plus b du dx plus dv dx, and finally we have plus c u plus v equals to 0. Now all I've done here is just added equation 1 to equation 2 and I've gathered my terms together. Now what do you notice? We can write this expression as d2 dx squared, okay, the second order derivative of u plus v, plus the first order derivative of u plus v plus c u plus v. Again, d2u dx squared plus d2v dx squared, because they are all functions of x, we can write it as d2 dx squared u plus v and d dx u plus v and c u plus v. Okay, keeping in mind there were a in front and a b in front here. Now, having said all that, what do you notice? This is just like your original equation with your y replaced by u plus v. So what we are trying to say here is, if y equals to u and y equals to v are solutions of this differential equation, so is y equals to u plus v. Take note of this. If y equals to u and y equals to v are solutions of this differential equation, then so is y equals to u plus v. So now let's look at a simple example. Okay, so let's keep this here and let's write a few things. Let's do a bit of differentiation and so on. Now let's say y equals to a e to the power of mx is a solution of this differential equation. Let's say. Now if y equals to a e to the power of mx is the solution, then it must satisfy this equation. So let's go ahead and write dy dx will be what? Let's go ahead and do that. Okay, dy dx will be equals to a m, we got that, e to the power of mx, and d2y dx squared will be equals to a m squared e to the power of mx. So this is simple exponential differentiation. So now we can go ahead and plug these into our differential equation and let's see what happens. Okay, so let's do that. Let's plug things in. Yeah, so we have got a, what's d2y dx squared? A m squared e to the power of mx plus b, what's dy dx? A m e to the power of mx plus c, what is y? A e to the power of mx equals to 0. So what have I done? I've just substituted all these that I've done here into my original differential equation, and now what we can do is we can do some cancelling. Okay, a is gone. Okay, a is gone. What else is gone? E to the power of mx is gone. Okay. Okay, so we are left with am squared plus bm plus c equals to 0. So we see we have got a quadratic equation in m. Am squared plus bm plus c equals to 0. So this quadratic equation, let's say the roots are m1 and m2. So now we can write one of the solutions as y equals to ae to the power of m1x plus, maybe I should do it step by step. Let's call this one solution. The other one will be y equals to be to the power of m2x. But remember, if this is a solution and this is a solution, remember u and v, so u plus v is also a solution. So a solution of this differential equation will be, let me draw it here, will be y equals to ae m1x plus be to the power of m2x. Now this is a solution of this differential equation. Now remember, this is a second order differential equation, so the solution of a second order differential equation must have two arbitrary constants. There you have it. Okay, now a second order differential equation, let's say we have to solve d2y dx squared plus 3 dy dx plus 2y equals to 0. So this is a second order differential equation. We are going to solve this now. What do? Replace d2y dx squared with an m squared. Replace dy dx with m and replace y with 1. So what do you end up with? You end up with m squared plus 3m plus 2 equals to 0. So this is a quadratic equation in m. It is called an auxiliary equation. So let's find the roots. So m plus 2, m plus 1 equals to 0. So m will be -2 or -1. So now we can write the solution straight away. Y equals to ae to the power of minus 2x plus be to the power of minus x. And we are done. Yeah? This -2 is from here, this -1 is from here.